I'm Anil Kumar. Welcome to my series on integration. Here is a test question based on displacement, velocity, and acceleration. Question number 7. An object moves along a straight line with its position measured relative to a fixed point O. Its acceleration at any time t is a of t equals to 6t. So we are given the acceleration as equal to 6t, where t is greater than equal to 0. Its initial velocity is minus 25. So at t equals to 0, velocity is equals to minus 25, right? And at t equals to 1 seconds, its position is 24. And at t equals to 1, displacement s is 24 meters left. So it is minus 24, right? So it is written 24 meters left, so minus 24 of the reference point, which we are taking as origin. Determine when the object is located to the left of the reference point, right? So this is to the left of the reference point. Okay. So let's try to work it out. So, well, first find, we are interested in displacement position vector on the left. So we'll have to do integral of acceleration to find velocity first, right? Which is integral of acceleration. So that is 6t dt, correct? So which is 6t square over 2 plus initial velocity v0. Now at t equals to 0, we are given velocity is minus 25. So v0 is given to us as minus 25. So we could write this as 3t square minus 25. Is that clear to you? So we get the velocity function, correct? Now let's find the displacement. So displacement will be integral of velocity, right? So that is integral of all this, 3t square minus 25 dt, right? So that is 3t cube divided by 3, so they will cancel, okay, minus 25t plus initial displacement. Now we are given that the initial displacement is minus 24 for t equals to 1. So we'll substitute 1 here and we'll write minus 24. Substituting 1 will give us 1 minus 25 plus initial displacement, and this is also minus 24. So we get this value as 0, right? So from here we can write down the displacement. So we get displacement as equal to, as initial is 0, so we get t cube minus 25t. Now the question is, determine when the object is located to the left of reference point. Okay, so we can factor this, right? So taking t common, we get t square minus 25. This is difference of squares. We can write this as t plus 5 times t minus 5, correct? So that becomes your displacement. Now, easy method here is to sketch the graph, right? So, zeros are at plus minus 5 and zeros, the right side is up, you know, so it goes to, since this is positive, right? So, we have a 0 at minus 5, we have a 0 at 0, and we have a 0 at 5, correct? Now, let me just sketch it, and then we'll talk about it. So, right side up. Perfect. So we have so the graph is like this. So what we notice here is that if I have a value of t, we have to consider t greater than equal to 0 only. So basically I should not be considering this half. So we'll only consider on this side, correct? So the question here is, determine when the object is located to the left of reference point, right? So since that is the displacement and displacement is negative in this portion, do you see that? So it is on the left of the reference point when the time is between 0 and 5, correct? So at this time it is on the left, right, of the reference point. It does make sense to you, right? So you could do like this, or you could also test the intervals, right? And this gives you an idea that at 1 it is to the left, right? That minus 24 indicates that at 1 it is definitely to the left, right? And it works well with the graph shown here. So I hope that helps. So some of you can also test the intervals between 0 to 5 and then from 5 to a greater number. So if I substitute a value which is less than 5, which in this case at 1 we know it is negative, right? And here it is positive. So if I write a value which is, let's say, 6 here, then all the three terms are positive. So when you multiply them, you get positive result, right? So displacement is positive. So that is how we are going to answer this particular question, right? So our solution is that the object is located to the left of the reference point when t is greater than 0 and is less than 5, correct? So it crosses the reference point at t equals to 5, perfect, seconds. So these are in seconds, right? Okay. So I hope that helped. In this particular case, there was no need to sketch this portion. I should not have been sketching since we are given t is greater than equal to 0, right? So we'll only sketch this side of the graph. Is that clear to you, right? And from 0 to 5, we see it is on the left side of the origin, right? Don't take this as the origin. This is where time is this. The displacement is negative for less than 5. So I hope that is absolutely clear. Feel free to write your comment, share your views, and if you like and subscribe to my videos, that'd be great. Thanks for your time and all the best.